Hey guys, how's it going? I'm Mr. Todd here, and I'm going to talk to you today about independent and dependent events. So, let's talk about what does it mean in just real life, not even talking about math terms. What does independent mean? What does dependent mean? If you think in terms of your family, most of you at this age are dependent upon your family, right? Dependent upon someone to take care of your basic needs. So you rely on someone else, okay? What does independent mean? That means, you're not relying on anybody else, you're on your own, and you don't need to have people doing things for you, right? Okay, in math, it's a little bit different. It's related, but it's a little bit different. If we're talking about independent events in math, we're thinking of things like coin flips. If you flip a coin, nothing changes about that coin from one flip to the next flip. Rolling a number cube. If you roll a number cube, nothing changes about that number cube from roll to roll, right? It stays the same. But dependent comes into it when we start thinking of decks of cards, bags of marbles. In those situations, it depends. When you're choosing from a bag of marbles, oftentimes you'll be told, well, if you take a marble out, you have to find out, in this experiment, does the marble get replaced before you take another marble out? Or when you take the marble out, does it stay out? Okay. If it's independent, when you take a marble out, before you draw your next marble, that marble has to go back in the bag, because then those events are independent of each other, and the probability would stay pretty much the same out of the total amount. The total amount would remain the same in the bag. But if we're talking about dependent events, when you take that marble out, it stays out. So that if there were 10 marbles in the bag, on your first draw, it would be a certain number out of 10. On your second draw, it would be a certain number out of 9. Okay? Let's do a problem together. Let's say that we'll do an easy one. There's 3 red marbles and 3 green marbles. Write that down. 3 red, 3 green in a bag. Okay. What's the probability? Now, we'll say that we're going to replace the marbles every time. So now we're dealing with independent events. What's the probability of drawing a red marble, then a green marble? Why don't you try to figure that out? You're going to multiply the two fractions. Okay, so if you did it correctly, you would have drawn out a red marble. It would be 3 out of 6, which is 1/2. And then drawing a green marble would also be 3 out of 6, which is 1/2. 1/2 times 1/2 is what? Raise your hand. Great job. 1/4. Okay, good. But now let's say that when you take the marble out, it stays out. All right. So let's see, what's the probability of getting a red marble then a green marble? Well, the first one would still be 1/2, but the second draw, there's still 3 green marbles in there, so it would be 3 out of what? No longer 6, but 3 out of 5. So it would be 1/2 times 3/5. Later in the lesson today, we can see this on the smart board where I have a bag that I so artistically drew, and you can actually see it on the screen, and we'll do that in a little bit. Cheers, have a great night. It's been a pleasure. Well, have a great day. It's night here, but when you see this, it'll be day. Bye-bye.